Hello students, in this video I am going to tell you the trick to calculate if a particular given compound is aromatic, non-aromatic or anti-aromatic. I have listed all the basic conditions that the particular compound needs to verify before we can call it aromatic, anti-aromatic or non-aromatic. An aromatic compound is a cyclic compound which has a planar flat ring. It must have sp2 carbons, sp2 hybridized carbons. It should have a complete conjugated pi electron system. That means it should undergo resonance. It should follow 4n plus 2 pi rules. That means the Huckel's rule has to be validated. All the structures which are aromatic, they have low energy and high stability. On the contrary, when I talk about anti-aromatic compounds, they also are cyclic. They have a planar flat ring. They are also always sp2 hybridized carbons. They also have completely conjugated pi electron system and undergoes resonance. But instead of 4n plus 2, it follows 4n plus pi rule. 4n pi rule. The compounds which are anti-aromatic have high energy and low stability. But whereas when we talk about non-aromatic compounds, they do not have a fixed set of rules. They can be cyclic or acyclic. It is not necessary that they are planar, and all the other conditions that we were talking for aromatic and anti-aromatic, they are not a kind of mandatory in non-aromatic. Now what we are going to do is we are going to calculate a value. Now what is this a value? A value is going to be the number of pi bonds plus the number of electron pairs outside the structure, outside the ring or the adjacent to ring, plus 1. When we will add all of them, we will get a value which we'll call it as a value. And if that a value comes out to be odd, I will call it as an anti-aromatic compound. And if it comes out to be even, I'll call it as aromatic compound. Now let's start applying the formula and see if we are getting it or not. Now I have written few compounds here for which we'll be checking their features, if it is aromatic, anti-aromatic or non-aromatic. Example for this particular compound, how many number of pi bonds you can see? I can see 3. 1, 2 and 3. And are there any number of electron pairs outside or adjacent? No, it is 0. So what is going to be a value? A value is going to be 3 plus 0 plus 1. So the answer is 4, which is even, and for even we know it is aromatic. Similarly, if I talk about this particular compound, how many pi bonds are there? The number of pi bonds is 1. How many number of electrons are outside? There is no electron, so this is going to be 0. Now you can also say that this carbon is sp3. No, this is not sp3. Whenever there is a carbon with a positive charge, or I call it as a carbocation, or a carbon with a lone pair, they both are considered to be sp2 hybridized only. So now here also it is 1 plus 0 plus 1, which is 2. Again it is even, so it is going to be aromatic compound. Similarly, if I am talking about a compound like this, number of pi bonds is 1 and number of electron pair outside. How many electrons are there? There are 2, so there is 1 pair which is just outside the ring on this carbon. So I will write it as 1. So the a value will be 1 plus 1 plus 1, which is 3, and it is odd, so it is going to be anti-aromatic. I hope the trick that I am explaining is clearly understandable. Now when I talk about a compound like this, here this carbon, this is sp3, right? So you will not have anything, this is non-aromatic. So the moment you see a carbon which is sp3, you can directly say that this compound is non-aromatic. Now if I talk about this, how many pi bonds are there? There are 2 pi bonds. Any electron pairs outside? No. So it is 2 plus 0 plus 1, which is 3, and it is again anti-aromatic. Now if I talk about this, how many are there? There are 2, but this carbon is also sp2, so it is not non-aromatic. And when I talk about this, this is 0, so this is 2 plus 0 plus 1, which is 3, and it is again anti-aromatic. Now when I talk about this, this is 2. The electron pairs outside is 1. So it is 2 plus 1 plus 1, which is 4. So it is aromatic. In this particular compound, number of pi bonds is 3, but I have a sp3 carbon here. So this is directly going to be non-aromatic. Now about this is having 3. The number of electron pair is 0, but this is sp2, so we are going to consider it. So 3 plus 0 plus 1, so it will be 4. So it turns out to be aromatic. Now when I talk about a compound like this, I have 2 carbons which are sp3 here. So again it is non-aromatic. Similarly, when I talk about this, it has how many pi bonds? It has 3. How many pairs are there? There are 2. So it is 3 plus 2 plus 1, 6. So it is aromatic. Now, there are few more compounds which will be a little confusing. So I also want to take them up here. If I have a compound like this, now this is a heterocyclic compound wherein one of the carbon is being replaced by an electronegative element, that is nitrogen here. So now if I say how many pi bonds are there, there are 3 pi bonds here. So how many electrons are there outside? See, now this is definitely a electron pair which is outside, or we can say it is adjacent to the ring. But we are not going to calculate, not take this into consideration while calculating the A value, because we only use the lone pairs or the electron pairs which help in resonance. And even if I do not have this lone pair here, still the resonance would be going on. So this lone pair is of no use for me. So it is 3 and it is 0. So it is 3 plus 0 plus 1, which is 4. So it is aromatic. I will take one more example so that this also gets cleared. Now if I have this compound, the number of the pi bonds are 2. But without this lone pair, my resonance will not occur. So I have to include this. So this is going to be 2 plus 1 plus 1, which is 4, and this is aromatic. Similarly, let's say I have, I will take it like this. It has 2. Yeah. So now if I say number of pi bonds are 2. But here, this pair is helping in resonance, this is not helping in resonance. So I will only count that electron pair which is helping in the resonance. Please keep this thing in mind. So this is again going to be 1, so it is going to be 2 plus 1 plus 1, 4. So this is also going to be aromatic. I hope the trick is clear and you will be using it in your exams. If you like the video, please considering subscribing to my channel so that I can come up with more videos for your use. Thank you.